there is a block of mass m which is hanging from a fixed rigid support through a spring of spring constant k. We intend to find what is the time period. Right now there are two forces which are acting on this. One is mg earth is applying a force, and there must be some extension into the spring, that is kx must have been there, and this kx must be balancing mg. So mg is equal to kx, right? So this is the first equation we get. Now we are more bothered, that is whether if we displace it from its mean position, release it, then if it is going to oscillate, is it going to be simple harmonic motion? Because for simple harmonic motion, this condition is must, that is x should be proportional to minus y displacement. So what we do is, now we displace it by a small distance y. We have displaced over here. We have pulled it over here, now over here, and now we have released it. So right now also, that is mg is acting over here. Now there had already been extension x in the spring, y we have introduced more, so the total extension in spring is equal to x plus y. So that is total extension. X was already there, y is now we have added more. So now this spring will apply a force. What is the force? Total force kx plus y is the force in the upward direction. We are not saying this is net force. So this is the force now which will be acting on this is going to be kx plus y, but earth is also working in this downward direction. So now what has happened is, we have displaced the body from here by distance y. It has come over here, we have released it. It has been displaced by distance y, so that's why the total extension in this spring is going to be x plus y. As a result, the force which is being applied by this spring onto the block because of its extension is kx plus y. So k into x plus y is the force in the upward direction, and mg, earth is still applying a force in the downward direction, right? We have moved the body, we have displaced the body by distance y, so our problem remains same, that is we have to prove that is x is proportional to minus y. Initially what has been the extension like, we are not bothered. We have displaced from this equilibrium position by distance y, so we intend to prove that acceleration should be proportional to minus y. If this is the case, we can safely say that this is going to be SHM, right? So our point of concern is like this. Now kx plus y is the force in the upward direction, mg is the downward direction. So let's find out what is the total restoring force which is going to be in this direction. So obviously when it was in equilibrium position, we pull it like this and release it, it will go upwards only. Displacement had been in this direction, so restoring force or acceleration is in this direction. Certainly once again that is they are opposite directed, but let's say whether this is going to be SHM or not, whether acceleration comes out to be proportional to y or not, we have yet to establish that. So net force is going to be kx plus y in the upward direction minus mg. So this comes out to be kx plus ky minus mg. But kx is equal to mg, that is mg equal to kx. So this and this get cancelled. So restoring force once again comes out to ky only. So restoring force is equal to mass into acceleration. So m into a is equal to ky. So a comes out to be k by m into y. K is constant, m is constant. So it means acceleration proportional to y. And we have also seen that if when we pull it like this, then the displacement is in this direction, acceleration is or restoring force is in this direction. So they are opposite directed. So we can say acceleration proportional to minus y. So this is necessary and sufficient condition to prove that this is SHM. If this is SHM, we can use this t equal to 2 pi y by a. So t comes out to be 2 pi a is equal to k by m into y. So y by a comes out to be m by k. So this comes out to be 2 pi m by k. So in the quiz etc., where it is only multiple choice questions, it is advisable, instead of spending time upon how this equilibrium position has been achieved, that is mg is equal to kx, you directly displace it from the mean position and go for the extra restoring forces. That is, if we had not been bothered, that is how this mean position has been achieved, we just had been bothered, that is from here to here we have pulled it. So the extra restoring force is ky, and ky is equal to m into a, so we still would have got the same answer. This you can very well use in linear SHM questions also and the angular SHM questions also, where you shall be looking for the extra restoring torques. Over here we talk about the extra restoring force which comes into play when the body is displaced from its mean position by distance y. Similarly, when we do angular SHMs, where over there we will not be bothered, that is how the equilibrium position has been achieved, what are the torques acting right now, When we move it by angle theta, then we will be looking for what is the extra restoring torque which has come into play, and we put extra restoring torque is equal to I into alpha, and over there we will get the answer. We will do angular SHM in the due course.